name's Paul, obviously. I'm from a company called REX Bionics, and we're a company that's developing a robotic exoskeleton. Well, I'll start with the device first off. So this device is a therapeutic device. It's to allow people who are disabled, quite often with a spinal cord injury. It allows them to get out of a wheelchair, get into an exoskeleton, stand up, walk around and do exercises. As I said, it's a therapeutic device. It's not something they're going to be wearing 24/7. We're not at that point yet, but it allows someone to go to an exercise therapist, get some movement. That gives them a whole better quality of life. It allows them to train their upper body and their ability to move and hold themselves, and so you get a lot of benefits from that. The company itself, we're an Australian company, but a large part of the team are in New Zealand. We're what you call a startup company. So we weren't an existing company. Some inventors had an idea, decided to start developing an exoskeleton. So we have around 30 people working for us, and we're all over the world. Most of them are in Auckland, New Zealand, and they do the design and the engineering. I work in Sydney, and we have people in the US and the UK as well. I never really thought about it. It happened by accident. So my background is I'm an electronic engineer. I'm a bit of a geek. I've always liked working on products that excite me. So that's electronics, battery-powered systems. Started my career in England, developing anything from emergency systems for oil rigs to heated diving suits and pretty geeky stuff. I then moved to Australia and found a job working for a company called Ventricore, and we made a bionic heart, an artificial heart. And the reason I joined that was because it was electronics, batteries, it had a motor, all the kind of stuff I loved. And I worked with that company for about 10 years and just really enjoyed seeing the difference we made to people's lives. We were keeping people alive who otherwise wouldn't be. So that's how I got into bionics. And of course, when recently when REX Bionics asked me to come and see them, again, something very exciting, makes a difference to people's lives. So it was by accident. And I think in most things in life, if you do things for a time and you learn how to do whatever that may be, whether it's car design, whether it's medical devices, you get better at it. And that's why I enjoy working in bionics. Well, I suppose I moved from another role where I was a vice president. Vice president really is someone who looks after all the engineering, the design and the manufacturing of a product, whatever that might be. I suppose I got the role because over the years I started off being a product designer. I wanted to design better products, so I used to go and ask people what they wanted rather than trying to guess what people wanted. So I got very used to working with people, doctors, clinicians, and companies who provide things like batteries. So I got used to doing that, and I then got promoted to a lead designer and a manager, and I suppose then I just moved from companies from Ventricore. I moved to a company that made mass spectrometers, and that was an Australian company. And then I found REX and just moved across. I think the single biggest thing is making a difference to people's lives. You know, when I'm lucky that I go to visit patients, I try to understand how people use a device, whatever that is. So I get to see patients who spend all their time sitting down, looking at people's midriffs, all of a sudden being able to stand up and look people in the eye and move around. So I think that's the most important thing for me. I suppose I lead a team of predominantly engineers and manufacturing staff. So a lot of what we do is designing a motion control system. So that uses a lot of technology. We have embedded systems that drive the motors. That's electronics that drive the motors. We have to design the motors, and there's a lot of maths and mechanical engineering go into designing a motor, because of course it's got to be small, it's got to be very powerful, it's got to be able to support the weight of a body. So that's a lot of engineering. Science, less so in this role. In my previous role in mass spectrometry, we had a team of scientists who were designing scientific instruments. There's less science in this because we're picking and refining systems that already exist. So there's less discovery, more engineering. Art, I use less of that than I should do. When you look at any product, it's really, you know, if it looks good, if it's intuitive, if it's designed well, it's going to be a good product. I use this a bit less in my job than I should do. In previous roles, we've had people like graphic designers, as we've been designing, for instance, GUI screens, you know, PC screens that people use to interact with the device. We've used graphic designers there, and that's worked very well. And mathematics, of course, you can't do engineering without mathematics. You can't design an electronic circuit or a set of gears without using maths to analyze the problem and to solve it. Okay, the first and the biggest question is, what do the users need? And it's the question that most technologists and engineers forget about. We start with an idea of what we think the customer needs or the user needs, and we go ahead and design it. That's very true across many industries. I think the first thing we need to do is actually ask what the user, and in this case, the user's a therapist. The person who owns the REX and operates the device is a therapist. So what do they need? What do they need it to do? How long do they need it to walk for? What kind of movements do you need to do? I suppose the biggest challenge is it's in everyone's nature. If you have a clean sheet of paper and you're designing something new, you want to design the best of everything. You want to invent everything yourself. The biggest challenge is to work out what's the minimum the product needs to do. Often when you're developing a product, it can take many years to produce a great product. But what is the minimum you need it to do? And focus on that. Really focus on the hard problems to solve, rather than trying to solve every problem at once. If you try and solve every problem at once, you generally never finish. So I think that's the most important. Look at what's out there. you always don't try to invent anything that you don't have to invent. So look at what I call them, the competition, the other companies that are doing this, but also what people use exoskeletons in the military, or they're trialing them in the military, they're trialing them in the building industry. If you look at how robots work, there are robots we use underwater. So have a look at the way robots are used. Secondly, I'd say don't invent anything you don't have to. So there are batteries out there that can do anything you want. So don't try and invent a new battery. Buy a battery. Don't try to invent new motors unless you actually need to invent new motors. So try to get as many off-the-shelf parts as possible and bring them together in a system. Because again, if you try to do everything yourself and invent everything yourself, it's a long, long time it'll take.